All right, we're going to continue our study of two-source interference by talking about something called path length. Okay, so I'm going to label this A. This is source A here, and this is source B in the center. All right, and path length is different from the source to some point. So I'm going to pick a point. I'm going to pick this point over here. I'm going to label that point P. All right, and if you remember, we talked about last time that the difference between crests is one wavelength. So that distance right there is a wavelength. Okay, so path lengths. And we're going to do A to P. We're just going to count wavelengths from A to P. And A is making these circles, the ones that are centered on A. So I'm only going to count those. But I start from here, and I get to there, I get one wavelength, 2 wavelengths, 3 wavelengths, 4 wavelengths, 5 wavelengths. So AP is 5 wavelengths. Now, if I do it from B, right, I'm only going to count the ones that are centered on B. So there's 1, 2, 3. So B to P is 3 wavelengths. Now the difference in path length we're going to use delta PL for an abbreviation is equal to 2 wavelengths. 5 minus 3 is 2. And at point P, we know it's constructive interference, because at P, I have 2 crests meeting each other. Now I'm going to pick another point. Let's say right here. So be careful you're picking the same point. I'm starting here, I'm going down, and I'm going past where they cross, and I'm getting where this trough meets this crest. I'm going to call that point Q. All right, and I'm going to do the same thing. So A to Q. So I'm starting here and I'm counting, and I get 1, 2, 3. Well, there's 4, so I'm 3.5. 3.5 wavelengths. And then B to Q, 1, 2, 3, 4, 5. BQ is equal to 5 wavelengths. The difference in path length then is going to be 1.5 wavelengths, because 5 minus 3.5 is 1.5. And we know that Q is destructive. Now, and actually one thing that's kind of interesting, when we did our, found our central maximum and so on last time, the central maximum was down the middle. The first order, here's where the first order starts, and I'm just going to kind of sketch it in. I'm just going through where all the crests meet. There's my first order. And then my second order was here. And there's my second order. Oh, the difference path length for P was 2, and it's right on the second order. Now, if I do the same thing on the other side, here's my first order. And if you need to take a little more time, go ahead and pause the video and draw on the first order. There's the first, and then the second is over here. There's the second. The difference in path length for Q was 1.5, and it's right between the first and the second. And it's going to be destructive there. So if it's light, it's going to be dim. Sound, it's going to be quiet. So if the difference in path length equals m lambda, where m is an integer, that's going to give us constructive interference. Okay, so if it's a whole number of wavelengths different, you're going to get constructive. If the difference in path length is m plus 1/2 lambda. That's going to give us destructive. Okay, so everywhere along this line, the difference path length is 1 wavelength. That's what gives me the first order maximum. And it's going to be constructive. Central maximum of the difference path length is 0. It's the same length from A to that point to B to that point. So difference path length is 0, that's a whole number. This is going to be constructive. But if I'm halfway in between, the difference path length is going to be half a wavelength and it's going to be destructive.